All right, welcome back. We are looking at page 3 now for our exam one review for Math 120. So we're just continuing some of these topics. These next batch problems are all involve fractions, so we just have to be careful, make sure we write them in lowest terms and or as mixed numbers when applicable. So just be careful. Anytime you have that improper fraction as your final answer, switch it to a mixed number. So in this first problem, we just want to add. So we have some nice denominators, 16 and 2. And the reason why they're nice is because the first thing we should always check is to see if the smaller denominator divides evenly into the larger one. With adding and subtracting, we always should remember we need that LCD. So, but only for adding and subtracting though. So in this case, because 2 goes into 16 evenly, 16 must be our LCD. And so now the problem goes a little bit quicker. We can change our second fraction to have a denominator of 16 as well. First fraction stays the same. Now the only other thing to remember is that when you modify the bottom, you must modify the top. So whatever you multiply the bottom by to get to your new denominator, you have to do the same thing to the top. So our top becomes an 8. And now when we add, we do not add the bottoms. The bottom stays the same. But the top, we can add those to 11. So 11/16 should be our answer. Now, for something like number 10, the denominators are not nice because 20 does not go evenly into 32. So when we find our LCD, we got to do a little bit more thinking. So the trick is first decide, well, we know 20 doesn't go into 32. So remember the next step is to look at the next multiple of 32, which would be 64. And then ask the same question. Does 20 go into 64? No. So I mean, if you want to keep a running list up top, you can. So 32 was no go. 64 is a no go. Next multiple after 64 would be 96. That's a no-go. Next multiple after 96, if we add 32, that would be 128. Does 20 go into that? No. Next multiple after that would be 160. Ah, ding, 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 ding. So we know that 20 goes into 160, so that must be our LCD. So that means we get 160 here and 160 there. So same thing we did over here. We have to make sure we modify the tops accordingly. So to get from 20 to 160, we'd have to multiply by 8. 9 times 8 is 72. For 32 to go into 160, you'd have to do it 5 times. So if we multiply the top by 5, that would give us 15. And now we can subtract those. So 72 minus 15 would be what? 57, looks like. So 57 over 160. Now the only other thing you should check is, can we reduce that down? Are there any factors of 57 that divide evenly into 160? And I would say the answer is no. So there's nothing in here that would divide evenly into here. So this is your answer. And make sure you write it legibly. There you go. That's a little better. All right, next, we got some multiplication and division. Now, the one thing I will stress is that be very careful when you look at division. If you look at it from too far away, it might look like an addition problem. So get right up close to it. Make sure it's not division, because that'll make a difference in how you tackle the problem. But let's start with 11. So 11, we have a multiplication. Now, LCDs are out the window. We do not need LCDs when it's multiplication and division. But we can look to reduce the problem down a little bit. And remember, if we look diagonally and see that there's some relationships, we can reduce those down. So here we have 3 goes into 15. We know 5 times, so 3 goes into itself once. So again, you're just dividing both of those by 3. And that gets you those new numbers. Same thing here. 2 goes into both of those, but always try to go bigger if you can. 4 goes into both of those. 8 goes into both of those. So we can cross cancel. 8 goes into itself once. 8 goes into 16 twice. So now we have a lot smaller numbers to deal with, and we can multiply straight across. Don't cross multiply, straight across. So 1 times 2 is 2. 1 times 5 is 5. And the only other thing you need to check is what? Yes, the sign of your answer. So in this case, because one of our numbers was negative, we know that the answer better be negative. So negative 2/5 should be your answer on that one. Okay, so for this one, we have division. Now you can't really do much because we have a mixed number in there. So we don't want to keep that. We got to change that first. So don't try to do multiple steps at the same time. Just take it one step at a time. So 1 3/4 as an improper fraction better be 7/4, right? Whole number times the bottom plus the top. 1 times 4 plus 3 is 7. And the denominator always stays the same. So now we can do our same switch flip. Same switch flip. So the first fraction stays the same. Switch our division to multiplication and flip that second fraction. Now it's multiplication. So now we can do the same thing we did over here and cross cancel if there are relationships, which there are. So 7 and 7. So those can go to 1s. And so now when we multiply straight across, we get 4/9. No worries about positives and negatives. It was all positive. So our answer is positive 4/9, which my head is in the way again. So there's those quick fraction problems. Now, the second half of this page, so we got some converting rational number into a repeating or terminating decimal. Use an overbar when appropriate. So remember, all you have to do is use your calculator. You really don't have to do too much. The biggest thing is make sure you use it right. If you're changing a fraction to a decimal, top number goes in your calculator first. So 9/20, so 9 divided by 20 equals 0.45. Done. Now, can you do this by hand? Of course. If you want to do it by hand, make sure that the top number goes on the inside of your long division. So you got 20 on the outside and that 9 on the inside. And if we wanted to divide this out, 20 can't go into 9, but 20 does go into 94 times. Bring down the subtraction. 20 goes into 105 times. So there's our 0.45. And you can do the same thing with the 5/12. Now for 5/12, 5 divided by 12, we get that. Now, that is not your final answer because you have to remember that your calculator is only got so many places, so it's going to round that last digit, and it rounds up or down as appropriate. So in this case, we can see that 6 is going on forever and ever, and that 6 would round up that last digit to a 7. So our answer is 0.41666 ... but it says to use an overbar. So only over what is repeating. So the 6 is repeating, so 0.416 with a bar over just that 6. Now, I did that a little dark, but you don't need to make it that dark. Okay, now the fun ones. Converting decimals back into a fraction, into a quotient of integers reduced to lowest term. So no decimals should be in your answer. Now, when it is terminating, these are the nice ones because all you have to do is count how many decimal places are in the actual number. So in this case, we have 2 decimal places. So automatically, we would have to put 100 in the bottom. 2 decimal places, 2 zeros. Easy way to remember it. But now the top number is just the 72. We don't use the decimal point anymore. So 72 over 100, and now we just have to reduce. So I think 4 might go into both of those. So if we divide by 4, top and bottom, looks like we get 18 over 25. And now, when you have a repeating one. These ones can be a little trickier because it's kind of an algebra problem if you want to do it right. So the first thing is to set x equal to the original number. So in this case, 0.585858, and we'll write a little bit of that pattern. Now, what you do next is dependent upon that overbar. That overbar is over 2 digits. If it's over 2 digits, it's very similar to what we did over here. 2 digits means 100. Same thing here. 2 digits that it covers means to multiply it by 100. So if we multiply it by 100, the left side becomes 100x, but the right side, when we multiply it by 100, the decimal point moves over 2 spots. So we would get 58.585858 forever and ever. Okay, so now what do we do next? We subtract. Subtract these two lines because all of these line up nicely and cancel out. So all you have left on the right side of the equals should be 58, but on the left, be careful. Think of this apples and oranges. If you have 100 apples and you take away an apple, you better have 99 apples left. So 99x. And now your final step is to divide. Divide both sides by whatever's attached to that x. So in this case, the 99's cancel, and so your answer should be 58 over 99. Now, be careful. Lowest terms is still in play here. So if this is not in lowest terms, you have to reduce that. But in this case, it is in lowest terms. So 58 over 99 for that problem. All right, so that wraps up this page. Stay tuned for the next one.